Imagine you're driving on a rainy night. The road is wet, your tires are splashing through puddles, but somehow you still have control of your car. Have you ever wondered what makes that possible? The answer lies beneath your wheels and asphalt. Today, we will explore two key properties that make asphalt one of the most reliable materials for modern road construction: friction and waterproofing. These qualities not only keep our roads safe but also extend their lifespan, making them essential for sustainable infrastructure. This is not just for engineers. This is for everyone who cares about their environment. We are Civicon Education. Join us and discover the unknown. Don't forget to like and subscribe. Before we dive into its properties, let's first understand what asphalt actually is. Asphalt is a combination of aggregates, crushed stone, and bitumen, a sticky, black binder derived from petroleum. This mixture creates a durable and flexible surface that has been used in road construction for over a century. Asphalt technology has evolved significantly, adapting to modern engineering demands. Today, specialized asphalt mixtures are designed to improve road performance under different environmental and traffic conditions. Why is friction important? Because friction determines how well vehicles can grip the road surface, ensuring safety by preventing skidding, especially in wet conditions. Imagine driving on a road with no friction. Every turn and stop would become a challenge, increasing the risk of accidents. Modern asphalt surfaces are engineered to enhance friction through aggregate selection. Rough and angular aggregates improve skid resistance. Surface texture: open-graded and porous asphalts help drain water away, reducing hydroplaning. Regular maintenance: road resurfacing and anti-skid treatments ensure long-term friction quality. Friction is a fundamental factor in road safety, directly affecting stopping sight distance and braking performance of the vehicle. Stopping sight distance. This is the minimum distance a driver needs to see ahead to bring their vehicle to a complete stop safely. It depends on vehicle speed, reaction time, and road conditions. A high-friction asphalt surface reduces stopping sight distance by providing better grip, allowing vehicles to stop sooner in emergencies. On low-friction surfaces, SSD increases, raising the risk of accidents. Braking retention time. When a driver applies brakes, friction between the tires and the road surface determines how quickly the vehicle slows down. If the road surface has poor friction, such as a worn-out asphalt layer, the braking distance increases, leading to potential collisions. Hydroplaning prevention. Roads with high friction reduce the chances of hydroplaning, where a layer of water builds up between the tires and the road, causing a loss of control. Porous and well-textured asphalt helps drain water away, maintaining friction even in wet conditions. High-friction asphalt is especially crucial for highways, sharp curves, and areas prone to heavy rainfall. For example, airport runways use specialized asphalt to ensure safe landings and takeoffs. Water is one of the biggest enemies of roads. When moisture seeps into the pavement, it can weaken the base layers, leading to potholes, cracks, and overall road deterioration. This is why waterproofing is a crucial property of asphalt. So, how does asphalt resist water infiltration? Bitumen as a natural waterproofing agent. Since bitumen is hydrophobic, it repels water and prevents it from seeping into the road layers. Proper drainage systems. Modern road designs incorporate porous asphalt or drainage layers to channel excess water away from the pavement. Advanced modifications. Polymer-modified asphalt improves resistance against moisture damage and temperature variations. Innovations like permeable asphalt are now being used in urban areas to allow rainwater to drain through the pavement, reducing flooding and environmental impact. Asphalt may seem like just a simple black surface, but it plays a critical role in modern infrastructure. Its friction and waterproofing qualities make roads safer, more durable, and cost-effective in the long run. With ongoing advancements in asphalt technology, future roads will be even more resilient, ensuring smoother and safer journeys for all of us. So, the next time you're driving on a well-maintained road, remember, the science behind that smooth ride is more complex than it seems. We will see again with another topic. Thank you.